Welcome to Brain Vision.
So to make a voltmeter, a resistor or series should be placed in series with the existing meter, which is shown by the green dot. This So this combination inside the green dotted perimeter is the existing meter, and in order to make a voltmeter, a resistor, let's call it R series, should be connected with this whole connection. So that's what we did as shown in the circuit diagram. So this is done so that the desired scale voltage corresponds to the full scale current of the galvanometer. Now we know that 25 milliampere produces full-scale deflection of the galvanometer. So the voltage drop across total meter must be 25 volt when the current through the meter is 25 milliampere. So V full scale, which is VFS here, we know that that is equal to I full scale minus the equivalent resistance of the whole circuit diagram. So this red, whatever is inside the red dotted line, we are taking the equivalent resistance of those resistors inside the red dotted line. Now, we discussed that V full scale must be equal to, so this is the voltage drop, the full scale voltage drop, so that is equal to 25 volt when the current is 25 milliampere. We need to convert that into amperes so that our units are consistent. And this is done because we know that this current produces a full-scale deflection of the galvanometer that's here. So the voltage drop across the total meter, like across these 2 points, should be equal to or must be 25 volt when the current through the meter is 25 milliampere. Now, let's solve this equation. So, what's R equivalent? Let's find that as well. So we have R series connected in series with these two resistors which are connected in parallel. So R equivalent will be equal to R series plus equivalent resistance of the parallel combination. And this equivalent resistance is RG, RSH over RG plus RSH. Basically, this for parallel connection, the resistances are added reciprocally, and that's what we did. And then again, we took the inverse of this to get this resistance. These kind of problems have been solved a lot of time in the previous problem. So I hope you have an idea of how to find the parallel equivalent resistance. So yeah, now let's plug this value over here. So we get full scale voltage equal to full scale current times R equivalent, which we calculated to be equal to this. And from here we can find the series resistance, which will be equal to full scale voltage over full scale current minus Rg times Rsh, which is the shunt resistance, over Rg plus Rsh. Now, let me just write the values that we are going to plug values for the resistance, the voltage and current. Oops. The value of the voltage and current are already written over here. Now for the resistance, so we have Rg equal to 33 ohms and the shunt resistance is 0.2 ohms. So we plug these four values over here and solve for the series resistance, and we calculate that to be 999.8 ohms. And this is almost equal to 1000 ohms. Therefore, the sensitivity will be equal to this resistance that we found, our series, over the voltage, which is 25 volt. And this comes out to be 40 ohms per volt.